All right, all right, all right. Good evening, ladies and gentlemen. We are looking live. Good, good, good. Okay, so today we're going to start out by trying to figure out pawn movement components. Um, we're going to start by using just the built-in pawn movement component and see where that gets us, and then if that gets us anywhere, and then we'll switch to a custom pawn movement component as necessary. I do believe we will need a custom pawn movement component eventually, because the pawn movement component is probably not going to replicate the movement of descent. If you excuse me for just 1 minute, though, before we begin, I will be right back. I'm going to drop you onto the logo for now and be right back. Alrighty, folks, sorry about that. In my rush to get it started here, I have missed a step. We are now getting started. So as I said, we're going to play with the built-in pawn movement component, determine how well that will work, um, and determine what we're going to need to change to make it work for a descent clone here. Yeah. So let's go ahead and open up the pawn class that we've been working with. This pawn class we built yesterday. Um, it basically takes in an enhanced input action as a 3D vector and rotates the vector that we got into the player rotation. And then every tick, it's going to set the linear velocity to the input vector that we pulled in, multiplied by a force scalar. And it's then going to reset the vector back down to 0 so that when we let go of the key, it will stop moving. And then it does the same for the angular velocity. This is, of course, this is a bit of a janky way of doing this. It notably requires physics to be turned on our actor, which is bad for control. It's bad for physics. It's bad for consistency. It's really bad for networking. So what we want to do is switch this over to use a movement component class, which is going to move the pawn directly. I think. The idea is that we should be able to turn off simulate physics down here and still have everything work. So we're going to go ahead and start by adding a pawn floating pawn movement. Okay. I don't know if that is the correct class or not. It's interesting that character movement is not available here. We might try and create a blueprint class derived from the pawn movement component. I bet this is exactly what the floating pawn movement component is. So okay. Let's go ahead and pull up the documentation for floating pawn movement and see if we can't get a hint on what we're supposed to be doing for actually setting the velocities and stuff like that and moving the thing around. No movement component. Yeah, we're going to pull up the documentation here. Whoa. Clicked on the wrong thing. Let's go. Movement component updates associated primitive component during tick. It appears to be derivative of pawn moving component as we expected. Movement component updates is a movement component that provides simple movement for any pawn class. Limits the speed of acceleration are provided. Gravity is not implemented. Functions apply control input to velocity. That sounds like exactly what we're looking for. Apply control. Nope. Well, we can start with this. Whoop. Okay, we get a trigger, we rotate it. World vector, that makes sense. This is interesting. I don't know where we're going to get rotation. I seem to recall running this last time. Apply control input to velocity. It has its own tick component. I wonder. Let's go ahead and delete this, and we'll go ahead and link this guy all the way through. And compile, save. And we're going to try running this guy. Oh, would you look at that? That really is all we needed to do. Now, of course, our rotation's all messed up. Huh. That's very odd to me that we don't call the the update directly. The pawn movement component contains a tick that gets called automatically by the engine, and that's where our physics gets updated. So for example, and what that should mean is that we can go into here and head into sphere and turn off simulate physics. Yeah, let's go and save that. Nope, turn it off. Save. Compile. Good. All right. So now if we hit play here again, we should be able to move forward, backward, but you shouldn't be able to rotate. See that? So we are now moving without physics, and I don't know if we're colliding or not. We'll have to check that. We're now moving without physics, and but we aren't rotating without physics. So let's take a look and see if we can get rotation working. Although add Okay, I want to load up our example character blueprint class to kind of take a look at what our character movement component looks like. We might have to get back to that in a second. All right, so we've got our add input vector here. And I have a feeling that I'm just getting a name wrong. So pawn components, pawn movement. Let's start browsing here. Pawn components, character movement, pawn movement. Add input vector, consume input vector, get last, get pawn owner, get pending, gives move input, stop active movement. Odd. Add force, impulse, velocity, disable movement, max acceleration. I am confused as to how somebody is supposed to do rotation with that. Whoops. Okay, so let's head back to our spaceship. Okay, add input vector. I don't see any way that this would become a movement. Or sorry, I don't see any way that this would become a rotation. So, it's probably back to the documentation. I do want to check something real quick here. Nope. Okay. Might need to restart Unreal. Add movement input. Okay, still not seeing rotation. So, you know what? I wonder if it's expecting us to set rotation directly. Um, hmm. Floating pawn movement. We got max speed, got accel, decel, turning boost. Turning boost. After force when changing direction, making turns have less drift and become more responsive. Okay, this is all part of the movement component here. Okay. Ah. Okay, stay down, you Unreal. It's okay. Okay. What? to rotate the character. Okay, so it is a direct rotation. That is incredibly weird to me, once again, that we are going to use a different system for rotation and movement. Wouldn't you have the same system handle the both of them? Anyway. This is a really weird way to do that. Hmm. Okay, this character. Right. Whoops. I scrolled right past it, didn't I? All right, I'll move forward. Add movement input. We got that part figured out. Great. Whoa. How do I close this? Ah. Get control rotation, then drag the rotator return value and drop it in for break rotator. Sure. And then okay. Once again, this isn't right. We're going to do this for each each of you. This is still a really silly way to do this. I suppose that's why they changed it to the enhanced movement. Add controller pitch input. Add controller pitch input. I've not been able to find this note. Let's take a look. Pitch. Add controller pitch input. Add input affecting pitch to the controller's control rotation if local player controller. Okay, that's odd. Let's look at how they use this. So when we get input axis lookup, we add a controller pitch input, and then we add a yaw, and we add a roll. I assume. Well, actually, they don't add a roll because they're huh? You know what's happening here? I know exactly what's happening here. Okay. So we have to remember that the Unreal Engine is designed for first-person shooters. So when you look up in a first-person shooter, your pawn doesn't look up. Your pawn doesn't rotate. Your pawn stays exactly where it is. All we're doing is rotating the player controller around the pawn. And because our static mesh is attached to the pawn, not the controller, we don't want... Well, that's an interesting thought. They do have a mesh attached to that. They have to move a mesh around for the other clients. But I'm wondering if you don't actually see that in the tutorials until later. Okay, this is just adding sprint and jump. Yeah, so what they're doing here is basically just moving the player controller around and adding an animation, which is not what we want to do. What we want to do is actually rotate the pawn around. So let's go ahead and to set that up. So we're going to set this up manually to start with, and then we're going to start looking into how to write our own custom player controller later. So let's go ahead and delete this. Okay, let's go ahead and delete all this. We can go ahead and delete this, and we can probably go ahead and delete Flyworld. And then this goes to this. Bang. Okay, great. So we probably are going to want to normalize some vectors here in a second. All right, so we don't want to set the physics angular velocity. We can set rotation. We can set actor rotation. We can add a local rotation. We can add a world rotation. Okay. I'm just pulling out all of my options here for setting up rotation. For this actor. And then of course we can set for the individual components and add for the individual components, but moving the whole actor around should be fine. I think. Worst case, we do sphere instead of self. Physics should not be enabled for this object. So, adds the delta to the rotation of this actor in world space. Adds the delta to the rotation of this component in its local reference frame. And this delta rotation is a rotator. So we need to figure out how to construct a rotator. Make rotation from axes. And you'll notice this rotator wants 3 axes. Okay. I'm not quite sure what those axes should be. So let's look up. Let's look this up. Make rotator from angular velocity vector. Unreal is very insistent on being the window in focus here. which spins using torque, and so I want to display an arrow. So we're normalizing, we're making rotation from X. I'm not certain why that works. Make rotation from X. Okay, sure. Sure. And what we want to do, so now we have an input rotation in world space. Now we've transformed this into a rotator, and we want to probably add that to world rotation, although it's possible we don't actually need to do that transform here because we have an add local rotation as well. I kind of want to normalize it first. We're going to be adding some LERPs and stuff in here. But for now, let's try this and see if we rotate. Yeah. Whoa! We definitely need to normalize that vector. We are moving way too fast. Okay, so normalize. Tolerance is interesting. Okay, so now we're normalizing the vector and then we're rotating, and that should help a little bit. We aren't resetting the vector. Okay, so we need to consume. We need to consume the vector. So we need to set this back to 0 when we're done. So when we get new input, this doesn't just get added on top. It's a little weird to me that that works like that, but we'll figure it out. Okay. Whoa, it is still moving fast, but we are stopping the spin. And we're getting some weirdness in our spinning. That's very odd. We tend to be getting locked to top or bottom, which in a Descent clone shouldn't really be possible. It makes me think that we are making the wrong rotation. I want to X multiply. And our default value for force scale needs to be 0.001 right now, I think. Basically, we just want to get this down to controllable. Okay, that's still not controllable. Let's add a couple more zeros. Did that just make it non-responsive? I think it did. Okay, that's actually kind of a good thing. That means we can get to non-responsive. Oop. So let's remove one of the zeros, see what we get. Oh, single zero loss, and we that kind of makes me wonder if I somehow didn't get this thing started correctly. Because this is only a factor of 10. I would expect a factor of 10 to not have that much of an effect. And yet it does. Odd. Still odd. We're still not getting any rotation. It feels like we have 0 or infinite here, and I'm not sure why. Okay. Let's bring this back to 1. And then what I actually want to do is disable my mouse input. So I can just do keyboard and kind of figure stuff out from there. So we're going to go into our project settings. And our, oh, nope, that's not the right place. Context drawer, we want to go into our input and our dev input. And we want to, is there a way to turn this off? Without deleting it? I don't think there is. We'll just go ahead and delete these. We'll add some more rotation keys in here as well. We'll do our arrow keys for this. And we are going to want to up, we're going to want to swizzle. I don't know which direction, so we're just going to leave it at the default. And we don't want to do anything else, so we can delete this. And then for down, we're going to want to swizzle. We'll also leave it at the default, and we're going to want to negate. We negate before swizzling. So negate, then swizzle. Okay. For left, we are going to want to swizzle. I think the left is going to be probably the unaffected swizzle, and we'll go ahead and switch this to our Z priority swizzle. And then for right, we will negate, and then swizzle, and we'll once again change it to our Z priority swizzle, and save. And what this will basically do is let us use keyboard inputs 1-to-1 to figure out our movement before adding in mouse inputs. It's very interesting. Okay, so we're finding out what the issue here is. We aren't. This feels like we're setting rotation. No, no, we're adding. But note that we're moving to a rotation. We aren't adding onto our rotation. We're moving to a rotation. Oh, that one will go forever. That's odd. Why will up and down go forever, but left and right get stuck? Now they're all going forever. Okay. And we also are not getting a proper rotator in here. So I think what we want to do is go ahead and just go ahead and set the action value directly and not do any rotation first, I think. And then we want to, instead of add actor world rotation, whoops, we're going to use add actor local rotation. And delta rotation here, and of course set rotation rule to 0 so we don't keep spinning. And force scale is 1 right now. And normalization should be fine. I think we're going to skip normalization for now. I do still want to multiply by force scale because I'm going to need that later. So we're just going to set this aside and save this and play. Nope. Minimize, click. Okay, so we got our movement here, and then our rotation is very, very fast. Very fast. And I don't think I'm quite understanding what make rotate is doing, making rotator is doing. So let's go back to our force scale and set this to 0.01, factor of 100. That might help. And now we're going to check the rotation again. This is still incredibly fast. And it does feel like I'm hitting, right? I'm hitting tap and I am getting to a specific point. And I'm pretty sure we're switching between those 2 points, which is absolutely not what I would expect. When I hear add rotation, okay, you know what's happening? I'm thinking my scale doesn't matter. I'm thinking my scale doesn't matter. Because we are making a rotator from the x-axis to the rotation world, and that just cares about direction, not scale. I'm also not sure make rotation x is the correct way to do that, but it might be fine. LERP. So what we want to do is LERP from I think this is actually B. LERP from don't want math, pawn, get actor, local rotation? Do I want the lerp on the local rotation? Nope, I didn't want to add actor, I want to get. Oh, this is add, this is add, this is add. Get actor rotation. Okay. Delete. There we go. So I'm thinking this is wrong. Let's look up how to use lerp. I need to make sure I understand alpha. That Unreal is deciding he wants to be on top again. It's very aggressive on that. Okay. How do we use lerp then? I'm not sure I want to do time-based. All right, so every tick I want to lerp. So this is just going to select A and return A. And then this is going to select B and return B. Whoops. But, okay, so I don't actually have to worry about adjusting the alpha. Because this is going to change every frame. Whoops, I am backwards. Got it wrong. Okay. So this is going to change every frame. So we are mostly this, but a little bit this. I was not backwards. Okay, we're mostly this, but a little bit this. And so this, we'll rotate this, which will cause a feedback loop to this, which will then rotate this. Right, so this will get closer and closer every frame. Okay. Well, that's not good. Okay, the good news is my keys are still working. The bad news is I'm essentially adding my current rotation onto my local rotation. And so I'm thinking that I don't want to do adding like this. I think I want to go ahead and set the rotation. And I want to set the rotation, set actor rotation. Okay, let's go and delete this. And what I want to be doing here is I want to get a rotation that's, and I want I want to create a rotation that is, so we're going to get the rotation, and then we're going to rotate this a little bit towards our input. Not quite sure how to do that yet, but we're going to rotate that a little bit towards our input, and then we are going to set the rotation to that. That actually should work. And we want to do force scale, which we'll set very low. And we want to multiply this by delta seconds so that our frame rate doesn't matter, right? So this is our frame rate correction. Frame rate corrected lerp here. Oops. Let's arrange things a little. That's not nicer. Okay. So taking in our delta seconds, we are getting our current rotation. We're rotating a little bit towards our input, and then we're setting our new rotation to be towards our input. Now, what this should mean is that we're going to constantly rotate towards 0. Shoot. That's not what we want, but that's a start. Okay, note that we're constantly kind of rotating towards the 0 point. If we go ahead and hit our rotation keys, we change our rotation target. But when we let go, it still wants to rotate towards 0. And it's taking forever to do that because we multiplied everything by low numbers. But let's go ahead and multiply things by a little bit higher numbers to kind of get a better idea of what's going on. For scale, let's do 0.1. Save, compile, play. Okay. Now I would expect this rotation to stop. It's not stopping. It might be stopping. It is stopping. Okay, so it is rotating all the way around and stopping. Great. So now what we need to do is rotate our target vector to our current rotation, I think. So we need to be, if input is 0, we want to be trying to rotate towards our current rotation. So basically no input, no rotation. It's not quite true, but we're going to figure that out in a second. So we're going to have a target rotation that we're rotating towards, and that target rotation needs to be we'll figure that out in a second. Basically, we're kind of implementing our own little physics simulation here, so we need to have momentum and velocity, and that's going to take a little bit to figure out. Okay, so I think we're going to try this. See what this does. I think we can also set our force scale to 1. I don't think that's going to move us too fast. So let's go ahead and do this. So we are rotating. Okay, we are rotating to our sphere in world space. That's fine. That's our root. Didn't work. Whoa, spacebar is vibrating. That's very interesting. Okay, so I think we're only rotating around a single axis. I think our make rotator is weird here. I don't like the vibrating. Okay, so we have an incorrect make rotator and we are still rotating to an arbitrary point rather than an additive input. So, despite our rotation being in world space, in local space. So, target is self, make rotation for max. I'm pretty sure this is the primary root of our issues. That doesn't make sense. It gives... Okay, so it is normalizing itself. Build a rotator only in x-axis. I think we might have to look up how rotators work in Unreal. Okay, we can rotate a vector. We can unrotate a vector. We can find look at rotation. For a start location to point at a target location. Doesn't quite. Find relative look at location. Find a local rotation for an object with a start transform to point at target location. That sounds interesting. I'm going to delete this because that's almost certainly wrong. Find a relative look at location. Okay. Quaternion from the vector's direction without any roll. I'm not quite certain what that means. Okay. Not what I wanted. Get actor transform. So, start transform, target location, return value. This has some interesting weirdnesses. I don't think this is going to... correction. This might work from 0, 0, 0. I don't think it's going to work from any other position. So, where is our player start located? Let's go ahead and set you at 0, 0, 0. We aren't moving. Okay, that isn't quite what I was expecting. It's behaving better. No, it's not. What? Okay. Why do we not appear to be rotating this vector? Why aren't we infinitely chasing this rotation? I'm liking the lerp. That makes things easier. Okay, rotate vector, return value. Okay, so let's go ahead and let's add a print here. Right, because what I'm expecting is that rotation world is going to have an input get rotated by the actor, and then when it's rotated by the actor's rotation, as the actor's rotation changes, our output should change. And if our output changes, then we should be looking at a different thing, or trying to look at a different thing. Play. Okay, 0. When I press a button, okay, there's a bit of a problem. Actually, resetting our vector is messing us up, I think. Oh, wait a minute. Okay, no, we're getting multiple input. The confusing thing is that we get to a defined vector here. That's a little weird to me. Wait. That's exactly what I want. Where was that? Let's go ahead and once again delete all this. Okay, yeah. Why isn't this an option? And why do I not have a vector input for this? Turn value. Don't want to lerp? What does this rotator do? I think I'm just going to lerp directly. That doesn't sound right to me. That might be right. With a... Like, it's not right, like, in this configuration, but it might be right if I go back to rotating this by the world rotation. Let's go ahead and delete this, and delete this. Move this all down here and make it more coherent. There we go. And save and compile. Okay, yeah. Well, my roll is backwards, and my left right's backwards, and my roll is backwards, but we have something. It's moving the right direction this time. It's still not continuing the movement, but it's at least moving the right direction. So let's see if this causes it to continue the movement. Right, so we want to take this and rotate our vector according to us. So, okay, yeah. No. Because 0, 0, 0 is still going to be behind us. Whoops, did not mean to move. Okay, so I think we're applying this incorrectly. Let's go ahead and bring this on through once again. So we have a rotator. I think there's just going to be add actor local rotation. And then, of course, we want to reset this. Our problem here is going to be speed. Yep. We'll see how this goes. Okay, 0, 0, 0, no rotation being added. Oh, that's backwards. But hey, that's interesting. I think it's just because of backward it feels weird. Okay, there's no acceleration here. That's fine. We can fix that. All right. We're finally getting our descent flight set up properly. Now, to be clear, this actually isn't set up properly. What we want to do is move this into a custom movement controller class so that instead of having all of this spaghetti in the pawn, we have all this spaghetti in the pawn, that we just have this in the pawn, right? So on inaction fly trackball, we add an input vector, and on inaction rotation trackball, we add a rotation vector, or rather, we add rotation. Probably not vector, just add rotation, and we have these three. So we can just break the vector and insert those three right there. And then we can also have different types of input. So we can say input trackball or input turntable here, and then have a different handler for that. Okay. So let's delete all this. We might need the scale at some point, but this is a good start. It is interesting that right now I'm pretty sure we are frame rate dependent, which is not what we want to be. So we'll have to multiply by delta seconds at some point as well. Delta seconds is the previous frame time. So this means that if you have lots of frame variance, you still have the same rotation speed despite that. If we multiply by delta seconds, we have to include it. So we need to go ahead and, which was it, left and right or backwards? Was roll backwards too? So up, down is correct. Left, right is backwards. Roll is also backwards. So let's go to, that's the wrong one. Close that. We are going to our project settings. We're going to our nope. I'm still used to the old input method. We're going to our input folder in our dev input here. And left, so right, we do not want to negate. Let's go and delete that. And left, we do want to negate. We'll just go ahead and drop the swizzle here below the negate just for organization purposes. ZYX and negate. Oop, negate. Negate. There we go. And then we need to do the same thing for our roll. So we want to delete this negate and add it up here. Just like that. Save this. Close. And if we hit play here, then we can fly. I don't remember doing so many roll adjustments in Descent. I'm going to have to load up Descent here in a little bit. Well, probably not tonight. It's already getting late. Anyway, so we're going to have to load up Descent and kind of check what our inputs look like, if this makes sense. This doesn't quite feel right, but I could just be misremembering. That feels good though. Okay, so we now want to implement acceleration. Basically, instead of adding, so we're going to start by, let's go ahead and multiply delta seconds by force scale. And then we want to multiply the resulting value. Yeah. Whoa, what just happened? A float times a float should not be a vector. I don't know how we got that. Float times a float is a float. Okay. So we want to go ahead and multiply our force scale by delta seconds and multiply it by rotation world. And this will give us a frame rate independent rotation speed, theoretically, with a scalable value. Now, we need to do momentum. We aren't simulating physics, so I'm not certain any sort of get momentum will work here. But we can go ahead and calculate that if we need to. So we're just going to do a couple tests here to get the right force scale set up. Okay, see this is way too low. And what we're looking to do here is set this as our maximum rotation speed, which this is way too low. I think we want to be rotating once around in about 4 seconds-ish. Let's go ahead and set this to 50. 50, if I can type. There we go. Four seconds sounds way too fast, and I'm counting it out in my head. But this is way too slow. Let's set this to 150. That's 3 times that speed. This feels a little bit fast. Yeah, I think this is a little bit fast. Let's go ahead and set it to 125. What's going on? Oh, I'm not in play. Like, why am I flying? Not pressing the... Whoa. No acceleration is jarring, but this feels right. This is about right. So, let's go ahead and set up some acceleration real quick here. To make sure we know how to do it. And basically what we want to know is our current momentum. And then we want to multiply that, or then we want to lerp to this vector from our current momentum. And I don't think lerp is the correct function for this, but it's close. Yeah, that's right. So our angular velocity is going to be a float. How do we lerp a float to a vector? No, I don't think this is actually going to work. We aren't simulating physics, remember. So if I return... Wait, no. It is a vector. Okay. So if I go ahead and print this, let's go ahead and add a print right here. If I go ahead and print this, I think I'm going to have 0 no matter what I'm doing. Because we aren't simulating physics. That is the angular velocity from physics. See? No velocity. Despite us spinning quite quickly. So, what we're going to need to do, we need to first check if there's some sort of built-in to do this. I don't think there is, but it's good to check. Yeah, all the angular velocity is in physics. So what we need to do is create a okay. So now we have a rotational velocity and a rotational input that we're going to be using to set this up. I do want to print rotational velocity every tick because I want to make sure I'm doing this right. Okay, so basically, how do we find our rotational velocity? We need to save our we need to save, let's go ahead and, well, this is not. So we need to save our current rotation. Get I had something for that. Okay, our so we're going to get our current rotation, and oh, and we need to store this in a variable. So this is going to be rot temp, and this is a rotator. Set rot temp. Okay, I actually think I'm doing this wrong. Let me think. So I was thinking that we set the variable here, and then we do the subtraction here, and we get the current rotation. But that's not really what we want to do. What we want to do is get the rotation from the last frame and subtract that from the rotation from current frame. So I think I want to move this towards the end. I just don't know how to break these. Okay. So at the end of all of this, we want to set our rotation to rotation temporary. Okay. In fact, we're just going to change this to rotation last. Okay. So this is our last frame rotation. And then on our current frame, what we want to do is set rotation velocity to No subtract function for rotation. So essentially what we want to do is subtract our current rotation from our last rotation here at the beginning. So our last rotation was set on the last frame and set at the end of the last frame. That set might still need to be at the beginning. And then we want to, if this was a float, I'd subtract them, but the rotation doesn't have subtract, so I'm not sure what we have available here. That's annoying that my context sensitive still thinks subtract is a thing. Okay, delta. That sounds right. Normalized A minus B. That's not right. Because the rotation velocity should be in a vector format. Still don't understand why a rotator is 3 axes. Not quite sure what we're going to be doing here. Kind of feel like we should be moving this set to immediately after all of this. Like so. Like so. Let's not create some sort of weird old loop. Wow, we have spaghettified this so badly. Pull this out. Okay. I don't even know what doing a delta between rotators actually does, so let's find out. Okay, 0, 0, 0, 0. Whoop. Pitch, yaw, roll. Right? It feels like I really just need to break this rotator out into pitch, yaw, roll. That's exactly what I need to do. Perfect. Okay. So what we're doing here is each frame we are getting so we are taking the last rotation. Oh, we have a potential error here. If the if we are not spawned at 0 rotation, we're going to get a delta here and we're going to move. So the first thing we want to do on begin play is go ahead and set rotation last to our actor's current location. Okay, and that way, no matter what our player start orientation is, we're not going to get any weird start rotations. Okay, so we are we're taking our current rotation, subtracting our last rotation from it with a delta, and then storing that in our rotation velocity, and then doing a little debug here, and then immediately setting the last rotation to our current rotation. Okay, and then we're going to do a bunch of rotation stuff after that. But what that means is that will give us our frame difference between the last frame and this frame. And we know how fast we're moving. And what we want to do is say we want to we kind of want to start to add an acceleration. We want to lerp between how fast we're going, so 0, and our rotation inputs. Yes. Okay. Our scaled rotation input, I think. So what we want to do is add a lerp here. I think just a normal lerp. Rotation velocity. Alpha, we do want a above 0 alpha 0.1, and we want to be the other way around. We want to lerp from rotation velocity to rotation input. We might have a problem there. Rotation velocity might be inverted from rotation input, which could give us a little bit of a problem, but we'll see. Okay. Oh boy. I think that was going fine until we hit the gimbal lock. Like, look how nicely that accelerates. But this one is on a gimbal lock right now. Okay. So, we'll need to figure out how to solve gimbal lock. Okay, so the next thing we want to do is we want to make a new variable, and we want to call this rotation excel. And this is just going to be a float. We're going to move it up here. This up here. I think I figured out how to solve my... Okay. And then we're going to get rotation acceleration. Move it to here. Save this. Compile this. Rotation acceleration. I think we actually want it a bit slower, so we're going to do 0.05. Whoop. Yeah, 0.05. And the other thing that I'm thinking that we want to do is we are getting a rotation here, breaking it here, and then re-getting a rotation here. I'm thinking that if we make a rotator here and then lerp the rotators instead of the lerp the rotators instead of the vectors, we're going to avoid gimbal lock. So delete this, go to here. Delete this. Bring this guy over here. And this guy. We once again set this up wrong. We want to rotate 2b from A by the acceleration. So basically what we want to say is we want to start at a rotation velocity, which starts at 0, and then head to our rotator that we just made. Okay? Which ends up meaning we don't need rotation velocity as a variable. Although that might be useful to turn into a variable just for readability purposes. So let's go ahead and save this and compile and go ahead and give us a start. Okay, we aren't moving initially, good. And now we are moving very slowly. We're going to have to change our debug. So we're moving very slowly. Whoops. And I'm not seeing any acceleration. So let's go ahead and delete all this. And increase our force scale to 300. And then we'll see what happens. Odd. It feels like, it feels like I'm not getting any feedback into the system. So let me think about that for a second. Meaning that I'm always choosing this value and this value, and then these values are not getting closer to each other, right? So it's important that these values get closer to each other. So the idea here is that as we add a local position, this value changes. Right? So as we add a local rotation, this value should change. Oh. Whoops. So what's going on here is we're setting this here. So this is always 0. This subtraction is always just the same thing because we're setting it before we're calculating this. Okay, blueprints can be weird. Essentially, when we get to here, it goes, okay, so I need delta rotation for this. What do I need for delta rotation? I need a lerp. What do I need for the lerp? I need I need a rotation accel. Okay, got the rotation accel. I also need a delta rotator. Get the so like when it gets here, it does everything over here. And so that basically means because it's getting here before it's getting here, this value is getting set too early. So what we need to do is move this set over here. Okay. So now, now we should be different than 0 when we set it. Right? We do this calculation, add the rotation, and then set it. That did not work. You'll notice we are getting zeros, just pure zeros for our rotation. So we are lerping between 0 and our max force. No accel. I'm thinking that I need a rotation velocity here still. Give me a second to think. I think that waiting until here to calculate. So previously I moved the set before add actor local rotation because I was thinking if I added the actor local rotation and then set it, when I calculated the velocity, I would have. I'm setting to the new thing. Yeah, this is still 0 because I do need to set this before this, but I need to calculate before the set. If I set this after this, then I'm already on the next frame's rotation. Okay. So I need to change rotation velocity to a rotator. So you all can come up here. Whoop. Okay, so we need to first set rotation velocity to this. We then, oh, there's an output there. That's kind of funky. We then need to set rotation last. Okay. And then we're going to debug print our rotation velocity. And then we want to lerp to rotation velocity. Like so. I think this works. Okay, we go up and whoa, bad news, we're still getting gimbal lock. So, a few thoughts. First of all, back to 125, please. And save. Second of all, let's go ahead and drop that rotation acceleration even further. I'm thinking 0.1, 0.01. Third of all, we can go ahead and remove the print statement. Let's not remove the print statement. We're still debugging gimbal lock. Let's go ahead and compile that and hit play. Okay, the acceleration is a little too low now. I'm thinking 0.2, 0.3. 0.02, 0.03. We can rotate infinitely this way, no gimbal lock. We can rotate infinitely the other way, no gimbal lock. We can... Whoa. Did we just cause gimbal lock? By spinning? What? I'm stopping that. Okay. So we're getting some sort of gimbal lock here, and I'm not sure I understand it. So if we just press rotation, we're fine. No issues. Right, and you notice our yaw pitch roll here is trending towards 0. Great. If I go ahead and now press this button, I just got in a fight and I don't understand it. Okay. So if I rotate just a little bit, just a little bit here, and then, oh boy, any off-axis rotation it doesn't like. Why? I think I don't understand rotators well enough to understand why off the top here. We are probably going to have to do some research. Okay. It might have to do with how we're getting our input. But our input is just fine until we start subtracting things. I was thinking maybe I can convert the rotation velocity to a float as a total vector size, and then add this into my multiplication chain. Or, yeah, add a lerp in the multiplication chain down here to get rid of it, to get rid of the gimbal lock. I keep saying gimbal lock. I don't even know if that's what it is. Right, so if I go, if I go up, okay. Pushing left induces a roll. That is not right at all. Skip the whole lerp thing. Let's kind of see if we can't figure out what's going on here. Up. Okay, I think I can see what's happening here. I am doing things, my rotations, my input rotations in local space, right? I'm adding local. And these lerp values are in world space. That seems like a problem. So, I believe this is as simple as that's not simple. There is no get local rotation because that doesn't make any sense. Like local rotation is always 0, 0, 0. So I'm thinking maybe I want to put the lerp on the input instead of here, but I'm not quite sure how to do that. Let's see. So we would have to subtract, so we'd have a target input and a current input and an input velocity. And our current input I don't like not basing it on the rotation. Let me think about this for a minute. Okay, here's the thought. What if we do this manually, right? Instead of adding local rotation, we manually rotate to world. Okay, so each tick, it makes more sense to do this on input, but each tick we're rotating the world and then rolling that direction. That makes no sense. That might make sense. Good, 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 good. Not good. See, this is the problem with that. B, it doesn't work. Oh boy. Right, if I'm level, this works fine. If I'm level and forward, this works fine. But if I turn, well, it still works fine. As soon as I roll, this stops working. Okay. Which actually makes sense. So let's not do that. Add actor local rotation. This makes things way simpler if I'm handling the rotation as a local. The problem is that this rotation velocity is not local. Can I rotate a rotator? unrotate that. Rotator. You can just add two rotators together. They'll add each element. Just convert to quaternarians and multiply them. Combine rotators, no. Note, okay. The description didn't sound like it did that, but combine rotators. Um, so theoretically, I'm unrotating the rotate velocity. But I could also be rotating rotate velocity further. Guess we'll find out. Okay, you notice this says 180? That's a bad sign. What? Okay, so we're going to be constantly adding rotation here. So that is a bad sign. And very, very quickly. That is not correct. Okay, so it feels like we are adding our velocity on top of our... So our velocity is in world space. How on earth would we put it in... Wait. I don't think we were flirting with gimbal lock when we were converting this to a vector. I think we were converting with the world space problem. And of course, this is no longer a good set, so we can break the rotator, break rotator. Make vector. I wonder if I cast to a vector, if it will do the same thing. We'll have to look into that. Okay, so rotation velocity, we can delete this, we can delete that. So rotation velocity is now in world space. So I want to unrotate to go to local space. And then lerp between this and this. With an alpha of rotation acceleration and try that. Well, it's not right. I'm a little confused as to why it's not right. That's a different behavior. Delete this. Let's go ahead and input. Let's input our unrotated vector here. See if we can figure out what's going on. Wow. Okay. Left and right feel correct. Correct. But pitching does not. Neither does rolling. And we get an infinite acceleration somewhere. So this unrotating the vector is not working correctly. Hmm. You know what, chat? My eyes are starting to go screwy. I think I need to uh, end the stream for now and pick this back up tomorrow because, well, it's been 2 hours and we made progress, but I am not quite sure how to make this rotation local. Because that doesn't really make sense in context. And I'm not sure how to make this rotation global, or world rather, because of gimbal lock stuff. So I will go ahead and stop here and think about that later. Thanks.